Hello. Okay, so let's start recording. This is the last portion of the foundation part of our course. All right, so let's talk about marginal revenue. Marginal.
We're working in with linear market demand curves. So they're inverse market demand curves of the form P is equal to A minus BQ. Marginal revenue is simply A minus BQ minus BQ, or A minus 2BQ, because the partial of P with respect to Q is negative B, taking simple derivative of this function here. So with linear demand, the monopolist's marginal revenue is twice as steep. It's 2 times the steepness or the slope of the inverse demand curve, but it has the same intercept, which explains why in this plot here, you have market demand up here, marginal revenue down here, and marginal revenue is twice as steep as demand, but they share the same intercept, A. Sorry, I just have to check that. Okay, so this will be a useful fact when it comes to calculating marginal revenue with linear demand. It's very easy. All you need is to know the inverse demand, and then you get twice the slope, same intercept, and that's your marginal revenue. So now let's talk about the welfare laws of monopoly. So this is why it's important for us to understand the basic perfect competition plot we had earlier. Okay, so we said earlier that QC here maximizes the sum of producer and consumer surplus, right? Okay. Okay, so what does monopoly do? Monopoly restricts output from QC to QM, and it creates this deadweight loss area here, which is composed of this upper triangle, which is a consumer loss, and the producer surplus, which is this one. Okay. One thing I'd like to point out is that even though there's a producer surplus loss here, the interpretation does not mean that producers earn less money relative to the perfectly competitive case. In fact, the opposite is true. A monopolist maximizes producer surplus. Okay, so that's what the whole marginal revenue equals marginal cost. That's what it does. So as you can see, this sort of parallelogram here, not a really parallelogram, this four-sided polygon here, this is the size of the monopoly or producer surplus, which by inspection you can see it's bigger than this lower half of the triangle here. Okay, so we know that the monopolist maximizes his own producer surplus. So I invite you to think about what this lower triangle means. Try to interpret that and refer back to our discussion on what the deadweight loss means whenever a quantity less than the competitive quantity is produced. Okay, so next let's talk about what the welfare loss is and related to some important and interesting concepts that we will learn and use throughout the course. Okay, so remember this formula? This is just the area of a triangle, and this is P minus MC. And remember, in a perfectly competitive market, the price there would be close to or equal to MC. Okay, and then this is QC minus Q whatever, the Q associated with this price. So remember, this is just the difference between this and this, where this is PC. Okay. Oh well. Correct. This one and this one, where this is going to be MC, and then the gap here is between QM and QC. Okay. Okay. Under perfect complement. But what you're trying to estimate in this one is price minus MC. So it's going to be PM minus MC because this is the value of MC at this quantity QM. Okay. PM minus MC. And then this gap here between QC and QM. So that's this formula here trying to calculate the area of this deadweight loss triangle. Okay? Okay. Okay, so what will we do with this? We express this as a proportion of total sales, so we divide it by PQ. So the P and the Q, they sort of divide it between these two different products here. And you use the fact that the elasticity of demand is basically this. This is the percent change in quantity divided by the percent change in price. Right? Where this is true because all you're doing is to move the denominator to the left hand side. So the elasticity of demand times P minus MC over P equals this, which is the percent change in quantity. Okay? Now, doing that, you will then simply just turn this QC minus Q over Q into this. So it becomes actually P minus MC over P squared times eta, which is the elasticity of demand, which is this guy, right? Because Li is just this. That's called the learner index, something we will learn in a few slides. And it's the gap between price and marginal cost divided by P, or as a fraction of price. And this one is actually 1 over eta as well, which we'll use in this next line. So Li squared is simply 1 over eta squared. But n divided by eta divided by eta squared, that's just 1 over eta. So in the end, you will see that the welfare loss as a fraction of total output is just 1/2 over 1 over elasticity of demand. Okay. For the perfect monopoly case, which is this one, and the deadweight loss as a fraction of current industry sales is simply 1/2 the Li, or 1 over twice the elasticity of demand. Okay. So let's pause here to think about this. So what this means is that once you have the learner index, or this estimate of the markup, this difference between price and marginal cost over price, then that will give you already a sense of the size of the welfare loss based on the triangle that we see here, right? Similarly, because we know that the learner index is just 1 over the elasticity of demand, we also have the expression of the welfare loss as a function of elasticity of demand down here. So what we find here is that the more elastic the demand is, the bigger this number, the smaller this whole thing is. So the welfare loss is smaller for an elastic demand at the equilibrium point. Okay. And it's opposite. If it's more inelastic, if eta is smaller, then 1/2 times 1 over eta becomes bigger, and then the welfare loss is bigger. So those are the two concepts that sort of allow us to get a sense of the welfare loss without having to draw the triangle. So in evaluating these estimates, there are two caveats. We implicitly assume that it's possible to have perfect competition in all industries, okay, which may be unlikely given costs and technology. Okay? So this is actually talking about fixed costs and sunk costs being high. We will talk more about technology and how technology can affect the market structure in a later video. But that's one of the things that can happen here. The next bullet here says, taken from data in which active antitrust enforcement has been the norm, these measures are an understatement of the potential for monopoly-induced welfare losses. So, what this means is that in areas in which there are not so much active antitrust enforcement, or it is not yet the norm, these measures that you can calculate in these jurisdictions are an understatement of the potential of the actual monopoly-induced welfare loss. Okay, so now let's talk again about the learner index. This is the concept of market power. One way to measure how well a market performs from an efficiency view is to look at the learner index. Now again, from an efficiency point of view, what you want is a perfectly competitive market with a price close to or equal to marginal cost of production. The learner index measures how far the outcome is from the competitive ideal. So there's this gap between the price and marginal cost, expressed as a fraction of the price. This directly reflects the discrepancy between price and marginal cost, and this captures what is of interest when it comes to the exercise of market power. So Li for competitive market, since competitive firms price at marginal cost, is 0 because price is equal to marginal cost. So it's bounded below by 0, so it can't be a negative number. And it can go all the way to 1 when MC is equal to 0. P over P. Okay, so it's between 0 and 1. Now, for a pure monopolist, the Li can be shown to be the inverse of the elasticity of demand. The less elastic the demand, the greater the price marginal cost distortion. So again, we write out marginal revenue here. And for profit max, we set marginal revenue equal to marginal cost. And so marginal cost is equal to this one, which is just marginal revenue. And I think we've mentioned before that because this is negative, marginal revenue is less than the price. Okay, so now we divide both sides by the price and rearrange. Okay, so we get this. Price minus marginal cost divided by price equals this term here. Notice the negative. And that's just 1 divided by the eta, or the market demand elasticity. Because as you can see, this is like the inverse, right? The market demand elasticity has the change in Q up top and then change in P below. But this is the reverse, so that's why you can write it as the inverse. So the learner index cannot exceed 1 and only reaches it if MC is equal to 0. Okay, because it's also based on this idea here. Right? Okay. The more elastic it is, the larger the denominator, the smaller this is, and the smaller the learner index is. And it's opposite when this is very small. When this is very small, this can become large. Okay. But there are limits, of course, to how large this can become, right? Because 1 over eta, okay, can only be 1. So that creates a bounds for what the value of eta is. Okay. So in other words, if this is at maximum 1, what is 1 over eta gonna be? What is the smallest eta that's possible? It's 1. Okay, so this is the market-wide learner index. With more than one but not a large number of firms, measuring the learner index requires an average of marginal costs. When the commodity is homogeneous so that all firms will sell at exactly the same price, then the learner index can be calculated as P minus the weighted average of all the marginal costs in the market divided by P. So this formula looks almost exactly the same as the other one, right? Except that the marginal cost here is just the average of all the marginal costs of all the firms in the market. And similarly, the greater the Li, the farther the market outcome lies from the competitive case, and the more market power is being exploited. So there's more of a gap between this and the weighted marginal costs in the market. Okay, so some drawbacks. A problem of market definition, which we will talk about market definition momentarily. Li can be difficult to measure, and it requires estimating elasticity of demand and marginal cost. Although in this course, we'll be talking more about how LIs can be estimated. So we'll be spending a lot of time on that. And a lot of progress has been made with that. And what I hope to do, basically as an economist, is to try to apply these same techniques to the Philippines. Interpretation can remain ambiguous. So depending on what the cost structure of the industry, the interpretation of the learner index can be altered. So sometimes firms will have a high sunk cost, and sometimes industries will have cost-reducing innovations, both of which require large market power or large learner indexes. Okay, but in these situations, the deleterious effects of market power is offset by these technological constraints. So this is an older document or a table from Aldaba 2003. In our reading list in some of the essays, I'll ask you to read the updated version of this paper. But I wanted you to point out, we haven't talked about concentration ratios yet, but these should be highly related to the price cost margins. And one of the interesting things I might want you to do is to go to the newest version of Aldaba and use some of your econometrics training. I'm going to ask you guys if you have some economics training. And I'm going to ask you to get the correlation between the concentration ratios and the price cost margins for the newest paper from Medallia et al. 2018. Okay. But these concentration ratios should also be measuring market power as reflected by these price cost margins. Okay. So one of the other messages here is that there has been in the past attempts to calculate price cost margins, and then we'll be discussing specifically this paper in class. Okay. Oh, not this paper, but the updated paper. Okay, and now I'd like to talk about just gonna create a thing, a white sheet, so we can draw. So now we wanted typically to talk about in class, right? This is the demand and supply, a market demand that's shaped like this, a linear demand curve, right? With A here, and this is A divided by B. Where B is the slope. Yeah? Is that right? Y, if Y is 0, then X equals, yes, that's it. Okay? But sometimes, that's not the only way it can be done. Okay? So sometimes, what if you had a more disaggregated style of interpretation? So let me just write something down here. Let's say that you have two customers. See? Very simple. One with a willingness to pay of 50 and one with a willingness to pay of 30. Okay? You can actually draw a demand curve based on this simple information, because like we said, the demand curve is just the horizontal summation of the people with willingnesses to pay. Okay, so let's do that. Let's change our color here. Okay, so first, at 50, there's just one guy with a willingness to pay of 50. So he's this guy, right? Okay. So when the monopolist sets a price, and remember, one of the rules of this curve here, and now the curve that we're drawing on the right side, is that the monopolist can set a price, and then everyone can decide whether or not to buy at that price. Okay, and there are two customers. The question is, if the price is 50, who will buy? Clearly, this guy will buy, but not this one. So the quantity sold will be this one. Now consider a price that's above 30 and less than 50, right? Who will buy? Well, not this guy, right? Not the willingness to pay 30, because it's still higher than 30. And it's only this high willingness to pay guy who will buy it. So from the monopolist's point of view, instead of setting a price of say 40, he will definitely set a price of 50. Now what happens if we hit a price of 30? Who will buy? Well, two people will now buy, which is why at the price of 30, boom, quantity is 2. So the market demand given these two customers here is just going to be this step function here. Okay? Now, as you can see, there could be more customers with lower willingness to pay or possibly higher willingness to pay. If it's higher, it goes to the left, and everything moves to the right. And if it's lower, then you make additional steps here. But let's say this is your demand, and you only have 2 customers, right? Now, what is your optimal decision? So this one you can logic it out. Do you set a price of 50? Well, let's figure this out. If price is equal to 50, we sell Q is equal to 1, total revenue equals 50. Now, if P is equal to 30, Q will be 2, and total revenue is equal to 30. No, 60 pala. Because it's twice of 30. 2 people will buy at the price of 30. Now remember, I have excluded all prices between 50 and 30 because that will be essentially this guy. And I've excluded all prices less than 30 because that will also give you a quantity of 2. So the only 2 things that are being chosen here is 50 and 30. Okay. So which one will you choose? Naturally, the profit maximizing one will be choose price is equal to 30. Okay. By the way, our marginal cost here is equal to 0. Okay. So you might ask, how do we relate this to the usual marginal revenue is equal to marginal cost? Well, if you remember one of our earlier slides, it says that marginal revenue is just equal to TR from 50 minus TR from 30. And that is what? Oh, sorry. TR from 30. Well, actually, 2, because the quantity is 2, and then the quantity is 1. But this is understood to be 30, and this is understood because the quantity is 1 is 50. The difference is 10, because 60 minus 50 is 10. So the MR is equal to 10, and the MC is 0. Okay, so in this case, MR is greater than MC. Right, where MC is equal to 0. Now you might ask, why isn't it equal? It's because you cannot actually sell any more than Q2. There is no further way for marginal revenue to continue to fall. In fact, moving from Q to Q3 is impossible. You cannot sell Q3. And that's why the end of the line, the lowest your marginal revenue can be, is 10. Okay? And if it were possible to move further down the demand curve, then you would still want to sell further. You would want to still increase your quantity to 3. Assuming your marginal revenue, by doing that, is a positive number, right? And it's greater than 0. The other implication here is that if marginal cost is greater than 10, then you will not choose to set price at 30 and sell 2. Okay, because as we can see, the marginal revenue from selling 2, moving from 1 to 2, is 10. And if the marginal cost from moving from 1 to 2 is greater than 10, then that means you'll want to sell only 1 unit, which is this one. Okay. All right. So I just wanted to point out that the same logic of marginal revenue and marginal cost works for these, disaggregated step functions for different consumers, as it does with this more continuous version of a linear demand curve. Okay, so the logic works either way. All right. So we'll be talking more about this in class. See you soon.